Alright guys, welcome back to my channel. This is going to be, I'm going to show you guys this in stages as I make it up. I'm just making up the board with the single LM339 to replace this circuitry. What I've done is I've stitched a VCC and a ground rail there and left a trace going off to the positive and negative for the chip. And then I've also left, left a negative trace here going up here, a gap in the middle trace, and then the other trace going up to positive so I can mount my 3 reference pots there. I'll have to cut breaks in the middle trace and run links across. So that's where I'm up to at the moment. I've also got a positive and a negative on the other side just in case I need it for something. Negative closest to the chip on both sides, obviously. I might end up sticking a decoupling cap over the chip, just like right across it like that, but it's not really necessary. I'll see how it goes, but yeah. All right, be back soon. Okay, so I've got my 3 pots on here, these 2 that are sort of closer together and have their center points isolated there. They're going to be our high and low ref points, and then this one down here is going to be the offset for the AND gate. That's the little decoupling cap that goes across the first input and the first comparator. I did say I didn't want to bother with a power line decoupling cap, and I want to keep the price down, so cheap pots, single turn, still 1 meg, and I just went in with a 100 nano disc ceramic, which incidentally is also what that is. So that's cheaper than me putting in, say, a 1 microfarad monolithic or a 0.1 microfarad monolithic. That's as cheap as it gets. All right, I'll just let everyone also have a look at what's going on the bottom too. Layout is a very important thing if you want your project to not only perform good but look good and not take too much space. Layout is a very important thing. All right, I'll be back soon. Guys, I just wanted to point something out. When you're making up a board, copying something onto strip board, an etch board, whatever kind of board, from PCB, breadboard, as you go along and get a little bit along the way, take everything off that you've done. So like the pots are on the board and they're attached to power rails. Take out all the power rails to the pots. I still left the pots because I still got to copy what I've done over, you know. Not that I really need it there, but I mean, it just makes it easier, you know. If I'm just saying this, you know, for those people who are starting out doing this sort of stuff, but as you go and make up all your traces and decide where everything's going to go, you know, obviously there's a lot of different connections to be made. So it doesn't get all convoluted and confusing, copy it from your breadboard to this as you're making it up, and just take things off as you go so that you know what you're looking at there. You still have to do there, basically, if that makes sense. Anyways, I'll be back soon. I'm getting hungry. I'm going to go get something to eat and come back and continue on this. We're almost done anyway. I've just put the pull-up resistors in there. If the LED was to be mounted on the board, which it's not because it's got to go in the front panel, but if it was to be mounted in the board, it would sit right there. So that's the pull-up resistor for the LED. Those are the 2 pull-up resistors for the first 2 outputs of the first comparator. Alright, I'll be back soon. Alright guys, just quickly, I just want to add something. As I'm populating this board, I've just come to the unused inputs on this comparator. Now, for those who are learning, I'm saying it's not for people who already know. I'm not trying to be a dick or anything like that. with your unused inputs on op amps and comparators and stuff like that, depending on the topology of the actual op amp or comparator, sometimes you can leave them floating, sometimes you have to tie them to ground, sometimes you need to tie the output also to a resistor. Anyway, you have to read the app notes in the data sheet to find out what you're supposed to do with it. But in the case of this, unused outputs are left floating and unused inputs are tied to ground. So these two inputs there have a link between the two of them, and then there's another link going to the trace that goes to ground. That's what those two links are for. Just want to point that out so people are aware of it, and if they want to learn about that, they now know and they can go and do some research and understand why that is the case. But don't leave unused inputs just floating. Can't do that. All right, I'll be back soon. All right, welcome back to my channel, everyone. There's the board. I'll just move the battery input out the way for a sec so you can see the whole thing. We'll have a better look at this in a minute. So I'll just get my multimeter. I'll just show you one pot. We have our low limit 2.9. The next pot we have our high limit. It's 3.2. I just can't get on it, see? And then our comparator, that's its threshold. Right, like I said, it's kind of current based. The two currents add up on those resistors at the summing point, and basically you need to feed an equal current into the other input so that when the two match, that comes on. Alright, so now I'll put this here on the battery voltage input. So I'll show you the rail voltage powering it is here, 7.89 volts. And there is the battery voltage. I'll go over to my power supply, turn it down to 2.8, light goes off. Back up to 2.9, lights on. 3.2, the light's still on. Above 3.2, the light goes off. So that's my low battery indicator. That's complete. So all that's left to do now is literally put it in the meter. I think I'll make that a separate video. I'm still going to get it uploaded tonight, but I'll just give everyone a quick look at the board now. I just attached the LED on there just temporarily just to show you guys, but it's obviously going to be attached to a cable and go off to the front screen. So that is the back of the board. I haven't cleaned the flux up yet. Yes, I do that. And that's the front of the board. And where it's going to sit, it's going to sit right there. It's just perfect. Now that plan came out alright, eh? Battery and linear regulator just fit in there. The boost converter fit on the back of the screen. The switch just fits in the side there. And then my charge module and that, and there's just enough room for my LED. You couldn't fit much more in here. I'd have to, if I wanted to fit more in here, I would have to go and, you know, like build surface mount boards and get a voltage supervisor IC and do things differently. Not the old school way, so to speak, and miniaturize everything. But like I said, I just wanted to get this done with what I got lying around here. I wasn't too worried about that. So I'll end this video now. You guys don't need to watch me pack up. And I'll upload it, and then I'll get to work on installing it in here, and I'll upload that video too. Alright, see you soon guys. Cheers. Sorry, just one more thing I know I just ended the video, but I was just walking away and I just realized, I just want to point something out for the keen-eyed viewers. If anyone noticed this was running on 7.89, 7.8 volts, that's because after I completed this, I put my scope on the output of my linear regulator and I adjusted the boost converter voltage until under load it was running the quietest, and that happens to be at 7.8 or 7.85 or 7.9, around that ballpark. That's why this is running at that voltage. So when I put it in there, the reference points will be bang on. Alright, see you soon guys, cheers.